Have you ever ordered something online? Waited, like forever for it to arrive?
Or maybe worse, it finally shows up and it's just not quite right.
Yeah, exactly. Wrong size, wrong color, maybe even damaged. It's so frustrating as a customer.
And it's a huge drain for businesses too. All those returns, the support calls.
Right. But imagine if companies could just slash those issues,
Yeah.
almost completely wipe them out.
Getting close to zero defects, yeah.
What if they could achieve this near-perfect precision from clicking buy all the way to your doorstep?
It sounds ambitious, doesn't it? Maybe even a bit futuristic.
It does.
But it's actually something organizations are actively working towards, and well, that's what we're diving into today.
Okay.
We're looking at this really fascinating intersection of, tried and tested methodology and some seriously powerful technology.
That's right. So our mission for this deep dive is to explore how they're pulling this off.
Yeah.
How they combine this powerful, disciplined approach called Six Sigma with modern, really scalable data platforms, specifically Databricks in this case.
Okay.
We're basically unpacking a project outline we found. It's titled Six Sigma Sales Process Optimization on Databricks.
Sounds specific.
It is. And we want to plot the core idea, show you how this kind of data-driven rigor can genuinely transform how companies operate.
Slashing that variability we talked about.
Exactly. Reducing variability, boosting performance, and ultimately making customers happier. This isn't just abstract theory, right?
No, not at all. It's about practical, measurable improvements, things that can save, well, potentially billions.
Billions saved, happier customers.
Sure.
That sounds like a win-win.
And that idea of saving billions, it really gets to the heart of Six Sigma. It's fundamentally about systematically cutting out waste, eliminating errors, improving efficiency.
Okay, so before we get into the tech side, maybe we should start there. What exactly is Six Sigma?
Good idea. Let's lay the groundwork.
So Six Sigma, it's essentially a disciplined, very data-driven way to eliminate defects or errors in pretty much any process you can think of.
Manufacturing, services, sales.
Right, anything. In our case today, it's about streamlining that whole sales and delivery flow. The big goal is getting to near perfect quality.
And they quantify that, right?
They do. They target this mind-boggling number, 3.4 defects per million opportunities.
Per million.
Yeah. Think about that. Out of a million chances for something to go wrong, you're aiming for fewer than 4 mistakes. That's incredibly precise.
And that precision, that focus, is why Six Sigma feels more relevant than ever today. Businesses are drowning in data, right?
Totally. Lakes of it.
But having data isn't enough. You need a structured way to make sense of it, to find the real insights, to figure out why things aren't working perfectly.
Okay, so Six Sigma provides that structure.
Exactly. It's the framework. It's like the methodical detective work needed to uncover those hidden problems and fix them properly, not just, patching things up temporarily.
So if we bring it back to the specific business problem in our source material.
The sales process optimization.
Right. We're talking about really tangible challenges, like reducing how much delivery times vary. You want that package to arrive predictably.
Definitely. Or improving customer satisfaction scores, making sure people are actually happy with the service.
And maybe the big one, minimizing product returns. That's a direct hit to the bottom line. Six Sigma gives you the tools, the methodology to actually tackle these everyday, really impactful problems head on.
And Six Sigma needs data. Lots of it. Clean data.
Which brings us to the tech side.
The other half of this power couple, as you called it.
Exactly. You can't hit 3.4 defects per million by guessing. You need robust data and powerful tools to crunch it.
Which is where Databricks comes into the picture for this specific project.
Right. The source mentions Azure or AWS Databricks. And what's key here is having a unified analytics platform.
Why unified?
Because for a data-heavy project like this, you need everything in one place. Ingesting the data, cleaning it, processing it, analyzing it, visualizing it.
Okay, so it avoids having like 5 different tools that don't talk to each other.
Precisely. Databricks provides that single integrated environment. It makes the whole Six Sigma workflow much smoother, much more connected.
So let's talk about the pieces, the tech stack they used. How does the data get in?
Good question. For ingestion, they use something called autoloader.
Autoloader.
Think of it like a smart vacuum cleaner for data. It continuously scans for new sales files as they land, maybe from stores or online systems.
And it just pulls them in automatically?
Yeah, but only the new data. So it's incremental. It ensures the system is always up to date, basically in near real time, without someone manually uploading files all day.
Efficient. Okay, so data's in. Where does it live?
It lives in Delta Lake tables. And this is pretty cool. They organize it in layers.
Layers, like an onion.
Sort of. Bronze, silver, and gold layers.
Okay, break that down. Bronze.
Bronze is just the raw data dump, exactly as it arrived, warts and all. Untouched.
Okay, raw. Then silver.
Silver is where the cleaning happens. You fix the errors, handle missing values, standardize formats, make it trustworthy.
Ah, the crucial cleanup step.
Absolutely crucial. And then gold.
Gold is for the refined stuff. Aggregated data, summarized views, ready for analysis and dashboards, like average delivery time per region or monthly return rates.
Okay, that layered approach sounds really smart. It builds in quality checks.
Exactly. It's fundamental for Six Sigma.
Yeah.
You can't have reliable analysis if your foundation, the data, is shaky. Garbage in, garbage out. Right.
Totally. So how do they do all that cleaning and transforming, the heavy lifting?
That's where PySpark comes in.
Python and Spark.
Yep. Python's super popular for data work, and Spark is the engine that lets you process massive data sets really fast across multiple machines if needed. It handles the ETL extract, transform, load, and all the statistical number crunching for Six Sigma.
Got it. And how do they make sure all these steps run in the right order automatically?
That's Databricks' jobs. It's the orchestrator. Like a conductor for your data pipeline, making sure the bronze to silver job runs before the silver to gold job, maybe scheduling it to run every night.
Okay, so ingestion, storage, processing, orchestration. What about seeing the results?
Visualization. For that, they use Databricks SQL dashboards.
So you get charts and graphs showing the key metrics.
Right. Updated regularly, giving people that quick view of performance, and for keeping an eye on things long term.
Monitoring?
Yeah. They use features like Delta Lake change data feed to track changes to the data itself, and audit logs to see who did what when. It provides traceability and accountability.
That whole stack sounds really integrated. Makes sense why they'd use a unified platform.
Definitely. It connects all the dots for a complex data project like this.
Okay, so we have the platform, the pipeline. Let's talk about the actual data they're feeding into the system. What are they collecting?
Right, the specifics. To really optimize sales using Six Sigma, you need details.
So the sources mention standard stuff, right? Like transaction date, storied, produced.
Quantity sold, unit price, discount applied, the usual sales receipt info.
And customer details, too. Payment method, customer segment, region.
Yeah, those give you context about the sale and the customer. But for this specific Six Sigma project, the really critical pieces are different.
Okay, what are they zeroing in on?
They're capturing delivery time days, how long it actually took.
Makes sense.
A satisfaction rating, probably from a follow-up survey on a scale of 1 to 5.
Customer feedback, crucial.
And a return flag, just a simple true or false, indicating if the item came back.
Ah, the defect measure.
Exactly. These three, deliver time, satisfaction, and returns, those are the core KPIs, the key performance indicators that the whole Six Sigma analysis revolves around. Without measuring these outcomes precisely, you're flying blind.
Got it. So you collect all this data, it lands in bronze, but then comes silver. That cleaning step.
Yes, and you mentioned earlier how critical this is. The project outline really emphasizes it.
It's just so foundational. Cleaning out null values, fixing wrong data types, getting rid of duplicate transactions.
I remember working on a project once where duplicate sales records completely skewed the revenue numbers for a week, caused a huge panic.
Oh, wow. See? It happens. This silver layer is like the unsung hero.
It really is. You can't trust any insights if the underlying data is messy.
So, specific things they do. Converting dates to the right format, removing weird stuff like negative quantities or prices.
Because, yeah, selling -2 items doesn't make sense.
Right, and standardizing things like payment methods, so Visa, and Visa, all get counted together.
Little things that make a huge difference for accuracy. You just cannot do reliable Six Sigma analysis without clean, trustworthy data from that silver layer.
Okay, cleaned up in silver, then it moves to gold. What happens there?
Gold is all about aggregation and creating those analysis-ready data sets.
So summarizing things.
Yeah. Calculating things like the average delivery time per store, or the total number of returns per product category each month, or the mean satisfaction score broken down by customer segment.
Okay. Rolling up the details into higher-level views.
Exactly. It prepares the data perfectly for those dashboards we talked about and for the deeper Six Sigma statistical analysis. It gets the data ready to tell its story about how the process is really performing.
Right. So data is prepped, clean, aggregated in gold. It's like sharpening your tools, as you said.
Precisely. Now we can actually put Six Sigma into action. We use this pristine data to get measurable insights, and that starts by nailing down the critical metrics.
Okay. The project outline was pretty clear on these. What were they again?
They focused on three main ones. First, delivery time mean and standard deviation.
Average delivery time and, crucially, how much it varies, the standard deviation part.
Right. The explicit goal is reducing that variability, making delivery times more consistent.
Makes sense. What else?
Second, the defect rate, which in this context is simply the percentage of products that get returned.
Okay, lower is better there, obviously.
Obviously. And third, the customer satisfaction mean, that average score from the surveys.
Got it. Delivery time, consistency, returns, satisfaction. Those are the big three they're tracking.
Yep, the backbone of the analysis. And this is where the math side of Six Sigma really comes in.
Okay.
The ultimate aim is to compute the process's sigma level based on how well it's doing on these metrics.
Calculating a sigma level.
Yeah.
What does that actually tell you?
Conceptually, it's a measure of quality. Lower variation, like a smaller standard deviation in delivery time, and a lower defect rate, meaning fewer returns.
That leads to a higher sigma level.
Exactly. A higher sigma level means your process is closer to that ideal of 3.4 defects per million. It's a direct quantitative score for process capability and quality. Less waste, higher quality.
Okay, that makes sense. But how do you know if the process is stable over time? Like, is it consistently good or bad or just randomly fluctuating?
Great question. And that's where you bring in one of the most powerful tools in the Six Sigma toolkit, control charts.
Control charts, I've seen those. They look like line graphs with extra lines on them.
Yep, that's basically it. They're fantastic visualization tools for seeing process stability or instability.
So walk us through one. What are the parts?
Okay, typically the horizontal x-axis is time. So transaction date in this case.
The day by day, week by week.
Right. The vertical y-axis plots the metric you're tracking, let's say delivery time for each individual order. So you get a dot for each delivery.
Okay, dots plotted over time.
Then you have a center line, usually shown in green or black. That's simply the average, the mean delivery time for the period you're looking at.
The average performance.
Exactly. But the key parts are the upper control limit, the UCL, and the lower control limit, the LCL, usually shown as red dashed lines.
The boundaries.
Yes, and they're calculated statistically. Typically, it's the mean plus or minus 3 times the standard deviation of the process.
Mean plus minus 3 sigma? Ah, the Six Sigma connection.
Precisely. These lines define the expected range of natural variation for a process that's stable or in statistical control.
So if all the dots are between the red lines,
It suggests the process is stable. The variation you're seeing is likely just common cause variation, the inherent random noise in any process.
but if a dot goes outside the lines,
That's a signal. It suggests something unusual. A special cause of variation might have happened at that point in time, something worth investigating immediately.
okay. So the source material had an example chart for delivery time. What did it show?
Right, the sample chart. The first thing you'd notice is that all the blue dots, representing each delivery's time, are within the upper and lower control limits.
So technically it's in control. Stable. Predictable.
Statistically speaking, yes, no special causes jumping out. But here's the critical insight. Just because it's in control doesn't mean it's good. Look at the width of that band between the UCL and LCL.
Right, it looked pretty wide on the example.
Exactly. The chart showed high variability within those limits. Delivery times were bouncing around anywhere from roughly 3 days up to maybe 7 days.
Wow, that's a big range.
It is. So even though the process is statistically stable, that 4-day spread might be completely unacceptable from a business or customer perspective. It might not be capable enough if the target is, say, always delivering within 4 days. Customers hate that kind of unpredictability.
Good point. Stable doesn't automatically mean capable or good. What else could you see?
Well, the chart didn't show obvious upward or downward trends or crazy cycles, which is good for stability.
Okay.
But you might notice things like maybe a cluster of points below the average line for a week or two, like in mid-January on the example. That could indicate a period where things were running unusually well. Why? Worth looking into.
Could you learn from the good periods?
Potentially, yes. And conversely, you might see occasional spikes, points getting close to that upper 7-day limit. While still inside the lines, if those spikes start becoming more frequent, it's a warning sign, an emerging issue to tackle before it goes out of control.
Okay, so the chart gives you clues, even when things are technically in control.
Absolutely, and that leads directly to action.
How so? What recommendations come out of looking at a chart like that?
Well, first, you definitely want to evaluate the process capability more formally, using stats like CP and CPK.
Oh, more advanced metrics.
Yeah, they tell you not just if you're stable, but if your stable process is actually capable of meeting the required specifications or customer expectations. Are we consistently hitting the target or just consistently average, even if predictably so?
Right. Is our in-control process actually good enough?
Exactly. Then you'd investigate the causes of that high variability. Why the 7-day deliveries sometimes? Is it specific regions, certain products, a particular shipping partner? You use the data to find the root causes.
So even if nothing's technically broken, the main goal might become shrinking that band.
Precisely. The primary target often becomes the reduction of standard deviation. Improve consistency. Get that 3 to 7 day spread down to maybe a much tighter 4 to 5 day window. That's a huge win for customers and planning.
Makes sense.
And of course, underpinning all of this is the need for continued monitoring. Keep watching the charts, keep tracking the metrics. Things change.
So the analysis isn't a one-off thing.
Definitely not. It's about continuous improvement. Which brings us to how these insights fuel actual changes.
Right, turning the charts and numbers into real-world improvements.
Yeah.
The source gave examples.
Yeah, really practical ones. Like, okay, we see high variability. Let's drill down, analyze those late deliveries specifically by region or shipping carrier, find the bottleneck.
Using the data to pinpoint the problem area.
Exactly. Then you can propose targeted changes, maybe switching to a faster, albeit slightly more expensive, shipping vendor, only for that one problematic region.
Ah, a targeted fix, not a blanket change.
Right, or you could even use the data to simulate the potential impact. Like, if we could reduce the standard deviation of delivery time by half a day, what would that do to our overall Sigma level and customer satisfaction?
So you can model changes before implementing them.
Yes, it takes the guesswork out. You make data-driven decisions about process optimization.
And the Databricks platform helps keep this going.
Massively. That's where the ongoing monitoring and automation really shine.
Okay.
You can set up those Databricks jobs we talked about to run daily pipelines. They automatically refresh all the KPIs, recalculate the Sigma level, update the control charts on the dashboards.
So the insights are always current.
Always current. You can even build automated alerts. Maybe if the defect rate suddenly jumps or the Sigma level drops below a certain threshold.
An email gets sent automatically?
Yep, email notifications or alerts in other systems sent straight to the managers or process owners so they know immediately if something needs attention without waiting for a weekly report.
That sounds powerful for staying on top of things.
It is. You can also automate weekly reviews of, say, return reasons or satisfaction comments, keeping that qualitative feedback loop going too. It's about sustained improvement, driven by automation.
And this whole system needs to be secure and trustworthy, right? Especially with sales and customer data.
Absolutely critical. The source mentions using things like Table ACL's access control lists to ensure only the right people can see or modify sensitive data.
Data security.
And Unity Catalog, which is Databricks' solution for data governance. It helps track data lineage, where data came from, how it was transformed, which is vital for trust and compliance.
Knowing the data's history.
Exactly. Plus, comprehensive audit logging we mentioned earlier, knowing who accessed what, who changed what, all essential for a mature, reliable data platform making critical business decisions.
It really paints a picture of a robust end-to-end system.
It does. And the amazing thing is this rigorous Six Sigma approach, amplified by modern data tools, isn't just a nice idea. It has a track record of delivering incredible results in the real world.
Okay, yeah, the source mentioned some big names. Who are we talking about?
Well, the pioneers, Motorola, they basically invented Six Sigma back in the 80s.
Right.
They famously reached that near-perfect Six Sigma level 3.4 defects per million, and the estimates are they saved something like $16 billion over about 20 years because of it.
16 billion. That's staggering.
Right.
Just from focusing on quality.
It shows the scale of waste that can hide in processes. Then there's General Electric, GE.
Under Jack Welch, right. They were huge proponents.
Huge. They really popularized Six Sigma beyond just manufacturing, applying it to services, finance, everything. They trained thousands, over 10,000 black belts.
The experts in the methodology.
Exactly. And GE estimated savings of over $10 billion, plus huge improvements in customer focus and how quickly they could get things done.
Wow. Another giant success story.
And one more mention was Honeywell, or Allied Signal, which merged with them. They embedded this process discipline really deeply.
What was the impact there?
Over $2 billion in documented productivity gains. Again, by systematically reducing defects, cutting down rework, making things flow better.
So these aren't small tweaks. These companies achieved massive, monumental gains.
Monumental is the right word. By applying that structured Six Sigma rigor, powered by solid data strategies, they fundamentally change their operational performance.
It really drives home the point, whether you're making a physical thing or delivering a service.
That variability, those inconsistencies, they're the silent killers of quality, efficiency, and customer happiness.
And Six Sigma gives you the playbook to fight that variability.
Yes, the structured approach.
Yeah.
And platforms like Databricks give you the modern tools, the scale, the speed, the automation to execute that playbook effectively on today's massive data sets.
Okay, so wrapping this up, we've really gone deep today into this powerful mix. Six Sigma discipline meets Databricks technology. We follow the data journey, right? From raw ingestion with autoloader.
Through the bronze, silver, gold layers in Delta Lake.
Using PySpark for the heavy lifting, calculating those key metrics like defect rates and standard deviation.
Visualizing stability, or lack thereof, with control charts.
And then translating those charts into concrete actions, targeted improvements, all automated and monitored.
It's a comprehensive approach.
It really is. And the core message seems clear. Combine the scalability and flexibility of a platform like Databricks with the proven structured rigor of Six Sigma.
And organizations can genuinely, systematically measure, analyze, and improve how they operate.
Leading to higher quality, less variability.
And ultimately, happier, more loyal customers because you're delivering consistently better outcomes. It builds trust.
Okay, so here's a final thought to leave everyone with. A bit provocative, maybe?
Okay, let's hear it.
If even processes that look stable on the surface, like the one in our control chart example, can hide significant costly variability. What overlooked inefficiencies, what hidden variations might be lurking in the processes you interact with every single day? Maybe at work, maybe even just in daily life.
Interesting question. Where are things less consistent than we assume?
Right. What's the one process you could apply a similar mindset to, even without a fancy Databricks setup? Just starting with that Six Sigma thinking. Measure, analyze, look for the variation. Where could you start identifying areas for improvement?
Food for thought.
Definitely something to think about. Thanks for joining us on this deep dive.
See you next time.